number 12 here, it's a limit as x is approaching negative infinity of the product of x times the sine of 1 over x. And what we would always want to try to do first with one of these limit problems is try to do plug and chug. Well, problems show up right away. If you put a negative infinity in for an x, you're going to get a negative infinity. And then you're going to multiply that by the sine of 1 over x. Now that's actually interesting and worth talking about. 1 over x, as your x value is approaching either positive or negative infinity, your denominator gets bigger and bigger and bigger while your numerator stays the same. So that becomes, if you think about it, like a 1 over 2, and then like a 1 over 3, and then eventually like a 1 over 10, and then, I don't know, like a 1 over 1,000. So as that x value gets bigger and bigger and bigger, the value of each fraction approaches 0. So we end up then taking the sine of 0 right here, which ends up as a 0. Now negative infinity times 0 is not one of the forms that we talked about in our notes right here that makes it okay for L'Hopital's rule to be applied. So we kind of have to be a little bit weird about how we do this. We're going to rewrite this guy in a weird way that we sometimes do to help us out here as the limit as x approaches negative infinity of, I'm going to leave the sine of 1 over x here, and multiplying by x is the same thing as dividing by 1 over x. Now, why in the world would we do that? Because now, when you let x approach negative infinity, once again, this angle here approaches 0, and the sine of 0 is 0. Down on the bottom, as this x approaches infinity, the value of that fraction on the bottom approaches 0 as well. And now when you get 0 over 0, that makes it okay for us to use L'Hopital's rule on this version of the problem right here. So now we can go ahead and apply L'Hopital's. It's the limit as x approaches negative infinity of the derivative of our numerator divided by the derivative of our denominator. So the derivative of sine of any angle is the cosine of the exact same angle times the derivative of the angle itself. And the derivative of 1 over x, that's x to the negative first power, is negative 1 x to the negative second. So that's like a negative 1. Oh, you know what I probably should have done? How about I make that a negative 1, and then the x squared I'll just go ahead and put down here on the bottom of that fraction. There's the negative 1 over x squared. And then, all right, now when I go to take the derivative of the bottom, 1 over x, well, that's the derivative we just took. It's negative 1 over x squared. And that was convenient because that x squared is going to cancel out with that x squared. And while I'm at it, that negative 1 cancels with that negative 1. So all we're doing now is we're letting x approach negative infinity, which makes this angle approach 0, and the cosine of 0 is going to end up equaling 1. So that should be our answer there for problem number 12.